After Delhi, we present you RALL-E. Large language models have demonstrated great progress in natural language generation. With a sufficient model size, LLMs emerge powerful in context learning abilities that can handle unseen tasks with a text instruction, which are usually called prompts, in a zero shot or few shot manner, which means without any example or without or with few of the examples. Moreover, the simple yet effective next token prediction task of LLM makes it easy to apply LLMs on other fields such as vision and speech synthesis as long as the data can be converted to discrete speech tokens. This research focuses on the language model of text to speech or TTS synthesis. Also, TTS can be modeled by a decoder only language model by using a neural codec to convert continuous waveforms into discrete tokens. These methods typically leverage tens of thousands of hours of speech data emerged in context learning ability that can clone a speaker's voice by providing a short audio prompt to the language model and thus have impressive performance on zero shot TTS. The problem is that due to the sequential generation property of language models such as codec language models suffer from poor robustness. The autoregressive or AR prediction style of language model though enables the model to generate speech with diverse prosody patterns, they can also cause bad cases with unnatural prosody. Also, since there is no strict alignment between text and speech, the models can omit or repeat word in the input text. This is actually quite different from TTS methods based on non-autoregressive or NAR generative models, which predicts all token at the same time. So that is where this new project RALL-E really shines through. RALL-E stands for this is actually the abbreviation of VALI-E, where R is for robust. It is a method to improve the robustness of LLM-based TTS. The core idea of RALL-E is inspired from the chain of thought or CoT prompting. In CoT prompting, the LLM is instructed to generate an intermediate result that is used as a condition for the prediction of final result. The CoT prompting breaks a complex task into several simpler steps so that can improve the robustness of LLMs, especially on hard tasks like arithmetic. To adapt CoT prompting to LLM-based TTS, RALL-E predicts prosody tokens, which means pitch and duration, before predicting speech tokens to stabilize the prosody. Given an input sentence, RALL-E first predicts phenom, level pitch and duration of that input, then predicts speech tokens conditioning on both the input phenoms and predicted prosody tokens. And you can see some of the detail in this are overview of this RALL-E. Also, give RALL-E utilizes the predicted duration to mask irrelevant phenoms and prosody tokens when computing self-attention weights, which is quite important. The core idea of RALL-E is CoT prompting. This is what needs to be remember that generates intermediate results to assist and stabilize the generation of speech tokens and improve the robustness of LLM-based TTS. To accomplish this, the researchers have proposed to predict two kinds of phoneme level prosody tokens, pitch and duration, before predicting the speech tokens. The distribution of prosody tokens are modeled together with speech tokens by a single transformer so that they can influence the duration and pitch of predicted speech tokens. Also, to further utilize the prediction duration to guide the generation and improve the robustness, they propose duration guided masking to enhance the alignment between speech tokens, phonemes, and prosody tokens learned by the language models. So this RALL-E is really good. And just a quick note on that VALI-E, which this RALL-E is based on. VALI-E is simply a decoder only LLM based TTS system that uses two transformers to predict speech tokens from the text. So that's it guys. I will drop the link to this paper and research in video's description. Go through it, looks really good. And I think all of these researchers combined who are from Japan, China, Hong Kong. I think wonderful work there. Let me know your thoughts. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.